Hello, and thank you for joining the webinar today. We're going to give folks another moment here just to log in, and we'll be starting very soon. Let's get started. Hello, everyone, and welcome to the 2023-24 Better Buildings webinar series, dedicated to bringing you the latest actionable insights from leading industry experts. This annual series is a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. Next slide, please. Today's webinar is Turning Insights into Action, Bridging Building Data Analytics and Work Order Systems. Before we dive in, there are a few housekeeping points I would like to cover. Firstly, please note today's webinar will be recorded and archived on the Better Buildings Solution Center. We will follow up when today's recording and slides are made available for you to download. Secondly, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located at the bottom of your Zoom panel. Next slide. My name is Elliot Crow. I am your moderator today. I work at Lawrence Berkeley National Laboratory as a technology researcher around building data analytics. Very happy to be here. Next slide. So we're going to start out with brief introductions. We'll have the welcome poll. We have two great presentations lined up today, and we're going to do our best to make sure we have plenty of time for your questions, which we're happy to receive at any point throughout this webinar. Next slide, please. Now, let's start with some ground. Oh, I think there was a poll that we were going to put in here. Is that right? Let's see. I will keep rolling. Okay, that's later. Apologies for that. So we're going to start with some grounding definitions for the building data analytics tools that we call Energy Management and Information Systems, or EMIS. On the far left of this graphic here, you'll see the range of data inputs that can be used through these building data analytics tools, though you do not need to use all of them for any single application. Now, any given software tool can incorporate multiple capabilities, and monthly data analytics is the first of those highlighted on this slide. Pulling energy and cost data from monthly bills helps with benchmarking, prioritizing efforts on the energy hogs in your portfolio, and can also help you track progress toward long-term energy reduction goals. It's not too glamorous in terms of analytics, but it can be a big step. And it's surprisingly common that building technicians and operators tasked with making buildings run efficiently never see the actual energy consumption and costs for those buildings. So it can be pretty significant organizationally. We go to the next slide here. We then look at energy information systems, or EIS. That takes that energy data analysis to the next level. So using interval meters, you can get consumption values at hourly or even finer resolution. And with monthly data, you can see how much energy you're consuming. With an EIS, you can see when you're using that data. So on the right of this slide, we have some examples. At the top, a heat map chart can flag hotspots of energy use, which may occur at startup, evenings, weekends. They're really good for highlighting when consumption trends change. For example, if someone overrides a lighting schedule, you might see that on such a chart. In the middle on the right, there's an example of a load shape analysis. How does energy use change between occupied and unoccupied periods, or between seasons? You can answer some of these questions with this kind of chart. The bottom chart on the right shows load profiles in a calendar format, and this can be really useful for showing changes in consumption patterns when you switch, for example, from heating season to cooling season. Now, aside from flagging trends and potential issues, an EIS can also be useful for ongoing monitoring of energy savings to help justify some of the investments you're making. Next slide, please. Next up, the main subject of today's webinar is really circled around FDD, fault detection and diagnostics. And these are tools that provide more actionable information compared to EIS, using data from your building automation systems, applying more sophisticated algorithms. They can point you to specific operational problems. So any building automation system will have a set of alarms, for instance, to tell you that supply air temperature is out of spec. An FDD tool goes further by analyzing multiple points in the system. For example, analyzing outside air, return air, and supply air. You can highlight some operational issues even though no single data point is outside of its specified range. FDD can also report on exactly when those fault conditions occurred, so you can look at some of those patterns too. Beyond giving you a list of faults, you also have some excellent visualization tools to help you really drill down on the root cause of these faults. So for example, an FDD tool might tell you a specific sensor is giving a continuous flat reading, and you can go directly to look at trend data for that component in the same platform. Next slide, please. Finally, automated system optimization tools, or ASO. These tools have two-way communication with the building automation system and can continuously adjust HVAC control parameters to optimize performance. In some cases, optimum might mean lowest energy consumption. In others, it may be driven by minimizing peak time costs. ASO tools are not so common as EIS and FDD, but they've been around a long time and maybe becoming more common as dynamic grid flexibility becomes important. Next slide, please. So here we see a view of how to integrate EMIS into your facility management processes. This is essentially monitoring-based commissioning. Hopefully this graphic here is self-explanatory, but I'll just call out one key piece on the right of this slide, the fact that you need a human in this loop to review the analytics, do some additional diagnostics, prioritize, and get the problems fixed. Our speakers today will be diving deeper on effective ways and tools for doing this. Next slide, please. So we've collected a lot of data on EMIS costs and benefits, and we'll touch on that briefly here. For EIS, we found median costs of 2 cents per square foot, median savings around 3% of whole building use. For FDD, the costs are a little bit higher, 8 cents, but the savings are also higher at 9%, meaning that in both cases you get investment payback around about 2 years. The link on the bottom of this slide gives you a location to look deeper into some of this data, some of these numbers that we collected over the past 5 to 8 years. Next slide, please. Now, for anyone who has not already signed up, please reach out to us and ask to be part of DOE's EMIS technology research team. This is a great way to stay informed on the state of the art and best practices around these kinds of technologies. We meet 3 or 4 times a year and love to connect with technology team members on some of our research work. Next slide, please. And finally, a quick word on some of the technical assistance and recognition opportunities available through DOE's campaigns. We'll share some links to these efforts in the chat, and whether you're looking to get recognized for great work that you're already doing or to get technical assistance to help you get to the next level, campaigns are here to help you, and we're very happy to talk to you about any of these that are managed not just by Berkeley Lab, where I'm employed, but other national labs as well. Next slide, please. Okay, so today we're going to be using an interactive platform for Q&A and polling. Please go to slido.com on your mobile device or opening a new window on your internet browser. Today's event code is #DOE. Now, if you'd like to ask our panelists questions, please submit them anytime throughout the presentation using Slido. and we'll be answering those questions toward the end of the webinar. And if you look at the list of questions in Slido, you can give a thumbs up to the questions that you like the most, so they rise to the top of the list, and we'll make sure those are the ones that get asked. Next slide. So we want to learn a bit more about you, so let's start off with a poll here. Please join us over at Slido to respond to the following questions. If you're having any issues, please message our tech support team by using the Zoom Q&A function. Let's see who we've got. A lot of contractors and consultants. Come on, higher ed, you can catch up. Local government, this is good. 12% in the other categories. Okay. A lot of higher ed. Good to see that. We've had a lot of past interaction at Berkeley Lab with higher ed. They're taking a really strong lead in a lot of these analytics, and that's a great match for Scott Selner being here from University of Iowa today. Okay, let's keep things moving. Thanks for responding there. Great to know who's in the audience here. We have a great lineup of presenters today. First, we have Scott Selner of University of Iowa. He is a controls analytical specialist, and he's been in the building automation field for over 30 years, installing, programming, and maintaining various systems, with 20 of those years being in higher education. Our second speaker today will be Gary Mullaney. Gary is a senior energy and water consultant with Kaiser Permanente, an integrated healthcare system where he supports affordability and environmental stewardship goals. Thank you both for being with us today. And with that, I will hand it off to Scott to kick off his presentation.
Hello. Yeah, I'm Scott with the University of Iowa, and I'm just going to kind of briefly go through our workflow and how we turn faults into action items and complete those tasks. Next slide, please. And the next slide. So this is our group, how we're set up at the University of Iowa. So we have two analytical response specialists. These two people are very experienced HVAC technicians, many years in the business. These two individuals deal with the fault detection and diagnostics tool on a daily basis, and either hand out the work to others within the University of Iowa, or take care of those issues themselves. We have a controls support person, that's myself. I can handle some of those issues. If it's beyond what I can handle, I turn it over to a team of control people or control specialists that many of them are much more experienced than I am. And so we can turn the work over to them, and they can get the work done if it's more involved programming issues in the BAS system. We have two engineers, a mechanical and electrical engineer. We can go to them for support if we need baselining or costs put to projects. And then we have our priority and planning. That's our area maintenance people. So that's a big group there. Our university is divided up into different subgroups, and we can hand the work off to them and get the actual work completed. Another member is our fault detection and diagnostics software. We have a provider, we have a support person with them. We meet with them every other week, and if we have problems with faults that we need to have modified, or anything to do with the FDD software, then they provide the help to us. Next slide. So I'm just going to show you here how we turn a fault into a work order, and we'll get into a little more detail in the next slides. So this one here, our two analytical response specialists start working left to right. We'll take a look at a fault, and anything they act on, they need to turn it into a work order in our CMMS. So we have a seamless integration with FDD and our CMMS. They can simply create a task, and that task then gets generated into a work order. So we push that information over to our CMMS. CMMS generates the work order, and then that CMMS pushes that information back to FTD software, and we can create the work order. And from there, we can divvy out the work, whether it's our analytical response specialists or our area maintenance people, then have a work order that they can act on with the information already in the work order. So we'll just demonstrate how we do a typical work order from a fault to a work order. So next slide. So this is kind of how we take a fault and decide how we act on it. So at first, our analytical response specialists take that fault and they kind of look at it and dive into it and find out, is this a valid analytic? And you can kind of, I won't go through every box here, but basically it's our workflow to decide if it's actionable or if it needs to go back to our FTD provider. And some of these faults are faults because they might not be set up correctly. And so that's how we deal with whether it's an actionable work order or it's a behind the scenes issue with the fault. And so as you can see, if it's a fault, we push it to the right, and then the work order gets acted on upon our maintenance staff, and then we have a closeout. So once the work's performed, we always make sure the fault's cleared before we actually close anything out. Or if we find out that the staff doesn't find any problems and it's still an issue with our fault, we have a way to get it back to our provider and work with it from there. Next slide, please. So this is what we see on a day-to-day basis, right? So this is an example of a fault that we had this spring when we were filling chill water coils. We had a fault for a leaking, we had a rise across the cooling coil and or a drop, excuse me. So what we found is in this particular situation, we had a leaky chill water valve when we filled the coils. So our analytical response specialist went out, verified the valve was leaking, and we turned that into a work order. So next slide. So from here, this is in our FTD software. They can click create a task, and then it auto populates certain fields. We then assign it to somebody. We can add notes to it, and then we have a box that we check that we want to turn that into a work order within our CMMS. So we click that, we populate everything that we deem necessary. Next slide. And so now this seamlessly went out, got a work order number assigned to it in our CMMS that gets populated back in FTD. And then the screenshot below there is what our CMMS software looks like. So there's the work order. You can see the notes are brought in from FTD, and then our maintenance supervisors assign the work to the technician that they want to go out and perform the work. So the work's performed. Next slide, please. The work is performed. The valve was replaced. That's shown in the top. That's in our CMMS software. Then, like I said earlier, we don't close any faults out until we know they've cleared. So we looked at some history on that particular piece of equipment. The coils not showing any faults. Everything's working fine. And then we close out the work order in CMMS, and we close out the task in FTD. Next slide, please. So this is a little snapshot of what we've got going currently and where we've been since we started with FTD. So on the left is kind of what we have going right now, current tasks that we identified and that we're in the process of taking care of, fixing. And then the table on the right is all the tasks that we've completed. And all this information is provided by our fault detection and diagnostic software. It calculates all that for us. Next slide, please. So where we're going next? Well, our fault detection diagnostic software, we're working on a new interface. And so with that, we're going to work on our workflow with our CMMS. It works great now, but we've got some room for improvement, and that's what we're working on. We're also looking at using FDD and condition-based maintenance. We're not very good at Iowa getting it FDD installed in new construction projects or for commissioning, so we want to improve on that. Getting more frontline staff involved, and that just kind of comes with time, and as people learn to accept FDD, we get more people excited to get involved with it. And so that's what we're working towards. We have Energy Cap that takes our PI data or utility data. We're working on some more integration with that. And we've also rolling out a new total cost of ownership program at the University of Iowa. And we want to use FDD in determining the life cycle and costs associated with those particular assets that are connected. And with that, that's pretty much all I have.
Thanks so much, Scott. I'm going to throw a couple very quick fire questions at you from the chat here. So how many facilities do you manage? What's the overall square foot? That's the first quick fire question.
Square footage, we're at about 6.8 million square feet that's connected to FDD. And I'm sorry, what was the other question?
And how many buildings, facilities is that?
About 46, excuse me.
Mm-hmm. Okay.
Yep.
Great, thanks. And what kind of controls do you have, if that is a quick question?
Yeah, we have Johnson Controls Metasys, and we also have Schneider Electric Continuum that we're phasing out and rolling into the new EcoStructure.
Great. Thanks for that, Scott. We had some other great questions coming in. I won't interrupt the flow here right now. We got those for after. And for anyone in the audience, keep those questions coming as I hand over to Gary. Take it away, Gary.
All right. Good morning, good afternoon, everyone. Next slide. Next slide. All right. So today I'll give you a quick overview just so you have a sense of the background of what our program looks like. Then I'll talk about, I want to focus on why we're doing this, because I think that's really important. And then I'll talk about the integration itself. It's not all that different than what Scott's got at University of Iowa. So there'll be a little bit less on that. And then I'll talk a little bit about our desired outcomes. What are we trying to get out of this? And finally, I'll try to spend the bulk of the time talking about really our lessons learned, because I know that's what a lot of folks want to know. Next slide. So for an overview, this is a snapshot of our overview of our FDD deployment. To give you a little bit of the background, we started with an RFP. So in 2014, did an MSA, eventually piloted through 2016. And then I came on board around 2017. At that point, we're starting to scale the program. And that's what we've been doing since. So our goal is to get our FDD and get implementation in all 40 hospitals we manage, as well as many of our 700 plus medical office buildings. So all the ones that the target is all of our campuses that have at least 100,000 square feet, but we are going smaller than that, but that's at least the minimum, is get those larger campuses. That's where we're going to get the biggest benefit. As you can see from the map, very different than the University of Iowa. We've got a lot of square footage, but ours is much more distributed, which has its own challenges. So with that, you can think of this as every deployment is almost its own team, it's its own implementation. So it's really, instead of managing one big implementation of monitor-based commissioning and FDD, it's managing just dozens of them across the country. So makes it fun, definitely keeps me busy. Our focus right now is really on adoption, and that's where the integration comes in, because I think that's going to be critical to driving adoption, which, as was mentioned at the beginning, like these are powerful tools. There's lots of tools out there, but if no one uses them, then you're not going to get the value. So you got to make sure adoption is really going to be one of the main focus once you've got deployment in place. Next slide. All right, so this is just at a high level what the process looks like. And so I want to get into sort of why are we focused on integration. So one of the pieces is, if anyone's ever read the book Switch, they talk about sort of you got to motivate the elephant, you've got to instruct the rider, and then you got to make the path easier and smooth. So this is focused on making the path easier. So as part of change management, you're trying to bring in a new technology, and you're trying to get people to change their behavior. So the easier and smoother you can make the path, the better. So the first thing we did was, because step one in all of this is you got to log into the software. So we did a single sign-on implementation this year that makes login a lot simpler. So it's easier. It just removes one barrier to getting in. So especially for those folks that aren't using it as often, even the folks that use it more often, if it's 2 clicks versus needing to go through and log in, it can just make it that much easier to get into the system as step one. Then as they go through, I like to think the left of the slide here is sort of the triage step, getting in there, reviewing the analytics, deciding if it's valid, just like what's very similar to what Scott's team does. They just do it in a more centralized way because of the way the campus is set up. Ours, we usually have a handful of champions at each site that are focused on this kind of triage step of reviewing the diagnostic. But you see the big part is right now, without integration, there's this sort of dual path. You've got to use your FDD tool, if it has one, to track the task within that tool. But then if you really realistically want to get it done, everyone's got a CMMS tool. You've got to also track in your CMMS tool. So that creates this redundant work, which honestly either slows it down because you got to do it twice, or it just doesn't happen, which I find the latter is what happens a lot. The teams that are successful do it, but it is definitely a pain point and slows down the process. So that's why we really wanted to target. If we can make that integration one extra click, that's going to really smooth out the process. Next slide. The second reason why we're doing this is part of a broader push to shift our focus. When this tool and this program really started, when I came in, the focus was really around energy usage and spend, carbon reduction. It was very much seen as this energy tool, powerful tool. And the more time I spent managing the program and learning about it, the more I saw that we had struggles. You're going to have the teams that really get it and understand the use, and they're going to adopt it. But a lot of teams, that's just not their primary focus. Operations and maintenance is their bread and butter. That's what they do day in and day out. So what I want to do is we're trying to shift the focus from seeing this as an energy management tool to more seeing it as a operations and maintenance tool with energy benefits. So this is going to help make that shift, because our CMMS is their primary tool. That's what they're in and day out. So if we can have things integrated, you're going to get a lot of value out of it. It's going to help that shift. Next slide, please. All right, so talking about our actual integration, we do a task level integration. So there is a human in the loop. Not every single fault that is identified by our FDD gets gets created into a work order. There is a human in there validating them, making sure we're picking the things that are actionable and then raising those to tasks. And then with one extra click, then it can get pushed over into our CMMS. So the actual technical integration piece is there's an API from Nivolo, which is our CMMS, and Nivolo is built on top of the ServiceNow platform. So that's our CMMS. That call does the API call over to Clockworks Analytics, which is our FDD tool. New tasks get flagged within Clockworks. So within the FDD tool, we'll flag them, and that's what's going to get called in the API. Every hour, they'll pull any new tasks that have been created and create a new work order. Updates go the other direction. So once that work order goes through the system, it gets assigned, it gets updated in Nivolo. So they've either completed it or they've started working on it. Those updates will then flow back to Clockwork so that both systems can be tracking the right information, and that's done on an on-demand basis. The sort of key piece to this, there's the technical, what I call the technical integration, which is what I just talked about. That in order for this to work, you have to map the equipment between the two systems. And I'm pretty sure this probably applies to everybody. Um, and this, you think of it as this is so that the two systems can speak the same language. Um, and so that's really, well, I'll talk more about, but that's really the long pole in the tent in this whole process. To a wide scale deployment, especially if you're further along in the process. Next slide, please. So our desired outcomes, so what we're trying to get out of this is really trying to improve adoption, like I said. So one of the things is bringing the full engineering team into the process. When you don't have, when everyone has to go into this new tool, review the stuff, and take action, it's a lot harder to get people to use a new tool. But if we can get that tool and integrate it with the tool that everybody's already using, so our CMMS is already what folks are using day in, day out, we can get that small subgroup to get into the FDD tool, use that, and then push the work that needs to get done into, and they can really unlock the use of the whole team. Because what I have found, especially with a distributed deployment and a distributed adoption like we have, a lot of it tends to get put on that one champion, and they end up having to do the entire process, and you really just can't get as much value out of it, and that person can get very easily kind of worn down and overwhelmed with all the work. But if we can really make this a team sport and a team approach, it's going to help things out a lot. It improves leadership visibility because right now our FDD, our program, as much as I try to bring it into leadership, it does get leadership visibility, but they're not looking at, those are an extra set of metrics. They already look at PM completion rate. They look at corrective maintenance. So if we can have this integrated with the things they're already looking at, it's going to give more visibility and really help drive that adoption. It also demonstrates an organizational commitment. Anytime you're trying to do change, you need to show that a lot of people can be slow to adopt change because they think it maybe is just a fad. It's going to come and go when leadership changes out. But if you can really show that there's a commitment and investment that the organization is investing, I think that can really help people take this serious. Just know that it's not going away. This is sort of inevitable, and they come along and they're a little bit more receptive. Finally, like I said, this enables that shift from being energy centric to being more facility operations and maintenance focused. And like Scott, we're trying to move towards condition-based maintenance. We've got some pilots in there, improving environment of care. There's a lot of these additional, we used to think of it as energy with these co-benefits of maintenance and comfort. I want to change that, sort of put it on its head and have the focus be maintenance and operations, with energy being one of those benefits. Next slide. So the status of the technical integration is in production. We have one site that has actually done some of the mapping, and so they're up and running, but it's very limited. Even at that one site, it's not all of the equipment. So the real focus right now is on that, what we call our EIN, so it's the equipment identification number, and getting those mapped between the two systems. So there's a lot of nuance that goes into that. You got to make sure that what equipment actually needs being mapped. Is it all of it? In some cases, we have to create new assets in our CMMS that we didn't have and track as assets before. For example, like our zone units, we didn't track those in most cases in our CMMS. Well, now we're going to have to create those in there so that we can get that level of fidelity. And so as part of that, we've got a pilot site up and running. We've got some early adopter sites that are working on implementing a playbook we created. We drafted a playbook, which really gives the sort of step-by-step how to do this. And then the goal is to start doing more of the enterprise rollout in 2024. So we'll have the playbook for self-service. We also are working on a larger ongoing sort of asset alignment process. And this will happen as part of that asset alignment, but the teams that want to jump in earlier, they can do it on a self-service basis. Next slide, please. All right, and finally to the part I think most people probably care the most about, what did we learn through this process? So to reiterate, engagement is critical to adoption and value creation. So powerful tools don't mean much unless someone picks them up and uses them. So it's all about driving engagement. In order to drive engagement, we're trying to make the path easier. So that's where the integration comes. It must be a team sport. Like I said, if you try to put it on one person, it's even if I've had teams that I've had sites that have been wildly successful with that one person, and then that one person changes jobs or leaves, and you're back at square one. You get the value, but you've lost that adoption, and you can slowly start backsliding. So really wanting to build it into our processes, build it into the way the team operates. And I think that's why getting things aligned to O&M and seeing the value from an O&M standpoint and not just from an energy standpoint is going to be really helpful. I'd say for the integration specifically, start early. If you are in the early process and you do an RFP, I would think about it. Maybe you don't pilot, maybe you don't use it in your pilot, but as soon as that pilot is successful and you've got organizational buy-in that you want to do this, I would spend the money to do that, start doing that integration, because it's going to make your adoption, it's going to make the adoption a lot easier. And it's gonna set you up for success later. It'll also make it easier if you're doing this along the way versus the boat we're in. We've got thousands of pieces of equipment that are going to have to get mapped, and so it's going to be a bit more of a task over the next year to do that work. If we were doing that along the way, it wouldn't have been so bad. Get buy-in from whoever manages the enterprise maintenance management system. Make sure they're bought in and they understand what you're trying to accomplish early, so you're not and that was one of the reasons we've been really successful. We had, I think, at the senior leadership levels within the organization, a real buy-in to what we were trying to do, a real buy-in to what we're doing. So they made sure when we rolled out our new CMMS in the last few years, they made sure that this was part of the integration plan. It wasn't the first thing that got integrated, but it was written into the plan so that it happened. I didn't have to go back later and fight to get it added. They had it already in there. So you can work through the nuances of the difference between what's in your CMMS and what's in your. That's going to be something you need to think through before you start doing your mapping, so that you can give people clear guidance. So that's my last point, I think.
Thanks so much, Gary. And also to you, Scott. Before we transition to Q&A, I just want to encourage all the attendees here to download our additional resources handout. You'll find this in the Zoom chat box to download that. And this handout contains links to resources from Better Buildings and our speakers on today's topic. We hope you find that useful. We are now going to move on to Q&A. If you haven't already, please take a look at Slido with this hashtag here. We do have some questions coming in already. I'm really happy we have about at least 15 minutes here to get through some of these questions. So I'm going to start from the top. This one got 3 thumbs up, and just a reminder to all attendees, you can give a thumbs up to the questions you vote for to be asked. So first question, I'll ask this, let's say first to Scott. So does FDD enable you to run your operations with a smaller team, or are you just making buildings run better with the same size of team, or something else?
I would say in the case of Iowa, it's the latter. Yeah, we did not increase staff at all. We redistributed some staff, and yeah, we're making it run better with the same size team. Our focus is to be on to be proactive on our maintenance, and this tool definitely helps us do that.
And Scott, same for you, Gary?
Yeah, I'd say the same. I think that first question is always an interesting one. We definitely have not, our staff has gotten smaller, but it's not as a result of this. We've been trying to use the FDD to help make our team work smarter, not just harder. And so some early signs from some of our condition-based maintenance is that we really could get some time savings from that. I don't think you're going to get it just you're not going to get it from the energy stuff, because that's really it's going to likely be seen as extra work. But if you can start getting into the maintenance and start doing condition-based maintenance, you could get some real time savings. But our goal is not about shrinking our team. The goal is running our buildings better, because there's always work to do that's not getting done.
Mm-hmm. Great. Thank you. Thank you both. And Gary, we'll stick with you for the next question here. We're always really conscious of not wanting to explicitly or implicitly endorse products, but the question always comes up. Could you just speak a little bit to your process and how you selected your FDD tool, and just make a quick mention of what tool that is?
Yeah, so I was not there when we did the original RFP, so I was not intimately involved, but we followed a fairly typical RFP process. We went out to the market with our requirements, and then I think we gave them some initial data for them to actually test it out. So we let them kind of show us what they could do, um, and this was back in 2014, so the market's changed pretty significantly since then. But there were a lot of different players, and from my understanding, kind of holistically is where we picked Clockworks, and so we've continued to use them since.
Thanks, Gary. Same for you, Scott?
Yeah, we went through an RFP process as well and selected Building Advisor through Schneider Electric, which is a Clockworks rebranded product. It's the same product. And then we have AssetWorks for our CMMS software.
Thank you. All right, I'm just going to go straight to the next question here. That's got 3 thumbs up as well. So if FDD indicates a problem, but then you find it's not an issue, how do you then eliminate that in future without disabling points that might mean you miss some real problems? Scott, you go first on this one.
Yeah, we can modify the faults at a building level per equipment or across a portfolio. So if and no 2 buildings are the same, right? So we can tweak those faults on an individual basis by a particular piece of equipment to eliminate the flags that are not real issues.
Okay, Gary?
Yeah, similar. I will just say that this can be a challenge. It's definitely something to think about. It should be a dialogue back and forth. We focus on trying to get the folks that are really well versed in the tool, in the FDD tool and their BMS, to do that, and try to, and our vendor does a decent job of kind of pushing back if something doesn't quite make sense, because quite often what will happen when you first deploy an FDD tool is they'll say, oh, that's not an issue, and it might just be that they don't fully understand what the tool is trying to tell them, or it might just be a gap on their side. So it needs to be handled delicately. I would try to make sure you got somebody who's bought in and understands what's going on first, to try to screen things out, so you can really clean up as many of your faults as possible, so you don't have those false positives. And then really you can kind of try to spoon feed some faults to your folks. I know Scott's team, I've heard him talk about, they really put the faults through the ringer before they let anyone see them, so that the technicians aren't getting any false positives. We could probably do a better job with that, but that's a big push, so that, because otherwise people lose faith in the faults early on, and then it sort of undermines your effort.
Yeah, that makes sense. I keep having all these follow-up questions in my mind, but I'm going to let other people's questions take precedence here. Let's go to the next question here. This is about what kind of resistance you've faced from all directions. So management above, funding, support for the organizational changes, and also from the technicians using the tools. What kind of things have you faced there? Gary, we'll go with you first here.
Yeah, so ours is so varied because it's so distributed. I find that we get less pushback from management when we do technicians, mostly because I think management can get it, but they're also not the ones who are going to have to do a lot of the changing. It's not changing the way they operate day to day. So a lot of times they will sign up for it. And so what I've pushed is, when we talk to them, make sure you don't just get like the facility director bought in, but we really get the chief engineer, the assistant chief, get those folks in the room so that they're bought in as well. Because if they're not bought in, your adoption is going to really, you're just not going to be successful. And so the pushback I get from management might be around cost. That doesn't happen that often. The cost is fairly reasonable in the grand scheme of things, especially when they consider their utility budget. And then, or we've been able to get a lot of ours deployed through capital projects, so that defers that higher first cost, and then the additional service cost it's pretty reasonable. So that hasn't been an issue. Sometimes management will push back if they don't think their team is ready, which, if they push back for that reason, then that's perfectly fine by me, because their team needs to be ready for this. We don't want to deploy it without their team being ready to actually use it. And then on the technician side, it's stuff like the faults. They don't, some of them, sometimes the folks that are really good at their BMS think that they don't need anything else. And so those are the folks that can be challenging, but usually it's a matter of the resistance is just you're asking the extra work with the CMMS integration. I think is going to help alleviate some of that, and it's just we don't have time for it, and a lot of that just comes down to prioritization. So getting the leadership bought in to make this, help them understand where this fits within their set of priorities and not see it as a separate sort of energy added work.
Thank you. Thanks for that. Scott, same question.
Yeah, we were lucky at Iowa. Our management was very proactive for FDD. They're the ones that pushed it, so that wasn't an issue for us. The resistance, we have had some at the technician level because there's kind of at times they think we're creating problems, but we're just helping them find the problems before they become a bigger issue, and that's changing now, right? So I think we're getting more acceptance by our building technicians now. It's just become a new way of doing work.
Mm-hmm. I'll maybe just extend that question here a little bit. And Gary, you'd mentioned about the whole risk of if the champion leaves, you want to make sure the whole program doesn't sort of collapse in terms of having that continuity. Presumably, you've both been involved in having to hire new people and add to the team, and there's kind of turnover in staff, etc. Are you finding that there are people out there with the skills you need to just drop in and start using these kind of tools? Or are you doing a lot of the training yourself in FTD or the CMMS once you've hired people? Maybe Gary, you can go first on that.
I will say training and the knowledge, kind of knowledge, skills, and abilities of our engineers is one of our limiting factors and a challenge we have had. Scott mentioned some of the sort of realignment of the team, and that is something we've tried to do. We don't have the centralized team that Scott has in Iowa. Ours is all decentralized, so it makes it harder to have specialized teams when your teams are smaller. But some of our regions have seen the need for that sort of BMS / energy / analytics sort of guru, and they've created a sort of a regional role for that, and then they can help really drive the change and drive the use, and they've got the skill sets, and then they can start. They do a little bit of spoon feeding, but they can start sort of training the engineers on it. And quite often, not all of the faults are terribly complicated. It's sort of sometimes it might be a matter of, all right, some of it's really programming based, and those you need to filter them to the right people. But then a lot of the things that are more mechanical aren't as complicated. And so if you can push those out to the team, even if you don't have a strong BMS background, you can still handle those. So it's a little bit of triaging the faults and getting them to the right people. But yeah, you definitely, the training has been a bit of a challenge in some regions.
Thanks, Gary. And Scott, same thing, just a question on recruiting, the skills you need and training, etc. generally.
Yeah, recruiting is always an issue. But as far as the training goes, from the fault detection software, it's for our product, it's got a lot of plain English results in the faults, and it really kind of points you to where you need to be looking. So that definitely helps. And from what I've seen with the newer, younger workforce or the people coming, they're more technical than I was, probably 25 years ago, right? So they're more savvy on their phone and their iPads, and software comes natural to them. So I think the training is easier probably when we get somebody on board, if that makes any sense.
Yeah, like getting that momentum, critical mass going. Yeah, thank you. All right, so we've got maybe another 5-6 minutes here. Let's get to the next one here. This could be a tricky one. Iowa's annual budget for FDD and CMMS. I will ask this to you as well, Gary, but anything you can speak to around like how you budget, if it's per square foot, anything broadly that you can share around budget side of things. And Scott first. Let's go.
I guess I don't have the exact numbers. Our integration with our CMMS, that cost there, I don't think is increased at all. When we brought on FDD, there was some behind the scenes work that needed to be done that we paid for. As far as the actual cost for FDD, I don't have that number in front of me, but in showing in those numbers that I had in my slide presentation, it's definitely paid for itself in the savings over time. So so from that standpoint, it's paid for itself.
Thanks. Thanks, Scott. And Gary, you kind of mentioned this sort of somewhat previously around how it's relatively low, but anything you want to add to that?
Yeah, I can't speak to the CMMS software. I'm not really involved in that. That's adjacent to my work. On the FDD side, I have zero budget. So everything we do is through our local teams. So it's either through our capital projects teams, we'll do a lot of the deployment that's a requirement on ours that for any new construction, or if you're doing HVAC work, if you're going to do more than, I think, 250,000 in control spend, you're required to include our FDD solution to make sure we make the most of that. So on a capital, it's a drop in the bucket. It's like a rounding error on a capital budget. So I've gotten really no pushback on that. At least once they've heard the numbers, they never push back. Before the numbers, they're like, hey, that's some additional cost. But once they see the numbers, they don't really push back on it. And then, yeah, the operating cost is pretty reasonable, especially when you look at, like, I've looked at how much has been, like, I'll look at all the faults and what's being identified by the FDD, and then I'll normalize that to square footage, and it's always significantly more than what we're paying. And considering that it's not just we're getting the faults, but we're also getting the service and the support from the team, that, yeah, that's I think it's a pretty good deal.
Nice. Thank you. And it looks like we've got 3 questions lined up here that all kind of circle around the same topic. So I will stick with you, Gary, since you're talking anyway. So how many faults typically get reported? What are the most common types of faults? And do you find that over time that's a reducing number or just a changing of the types of faults that are looked at? So we'll see if we can cover all 3 of those in a combo answer.
Let's see. Going back to my original slide, I had it was at 4.6 million diagnostics were run. It shows what the amount of fault. It's a lot. I try not to think about the volume, because sometimes that overwhelms people. And I tell them, like, the tool's really good at prioritizing. So don't focus on trying to, like, you're not trying to get to 0 necessarily. Just use it to prioritize what's most important. Some of that stuff because when you think about, like, if there's a fault on a zone, like, think about how many VAVs and, like, how many boxes you have. It can multiply pretty quickly. But if you prioritize, you can really get down to a smaller subset. The teams that are really well engaged, you will see a real reduction in the number of faults and the fault prevalence. And we also look at the fault priority as well. So each one of these faults are given a score from 0 to 10. And then same thing for any fault that has energy and they can calculate it, they'll give it the avoided cost. And so we've got quite a few sites that they're showing no avoided cost anymore, because they've eliminated all the energy stuff. They might still have some comfort and maintenance items that they need to address. But in that case, it's not trying to get to 0. It's just trying to limit it. The kinds of faults, it's all the same stuff I think I've seen on some of your slides, Elliot, that you've shown. So it's simultaneous heating, cooling, it's leaking valves. Yeah, so valve issues, sensor issues. We actually have, like, a clean bill of health that we do for new buildings. So for those, they should eliminate all the valve issues, all the sensor issues. Cycling is another pretty common one that's a maintenance issue. And then for energy, a lot of that is on the programming side. It's a matter of, like, you could have an optimized program where it's overrides, or it's so Scott can probably get into more details. We use the same tool, so I know he's closer to the technical aspect of it.
Thanks, Gary. And then Scott, let's just round things out. If you want to respond to that question, then I'll close up the proceedings here.
Yeah, very similar to what Gary said. I guess I would probably, we're running around 13,000 analytics that are run per day just in our portfolio, and about 4,000 actual results. And like Gary said, we're never going to get to zero, right? But what's nice is we can use the tool for as we go through change of seasons. We'll look for different things now as we're transitioning to heating. We'll look for other faults for that, or they'll come to the top. And likewise when we go to cooling. So yeah, about the same as Gary.
Great. Thank you so much. You know, you answered so quickly, Scott. I'm going to throw one more in because I see a popular question at the top there. I have to keep the answer somewhat brief, but does your FTD monitor energy directly? At what granularity does it flag? And what are the triggers for that? Scott, do you want to go first with a quick answer on that one?
Yeah, so what our FTD does is it takes into consideration all the equipment that's connected. So if we're at a VAV level fault, it takes into consideration the energy used at the air handler, and it also so it plugs into that, the motor horsepower and all that, our connected steam load, connected chill water costs. All those utilities are all used in the calculation for the fault.
Okay, thanks. Gary?
Yeah, so I think when, like Scott said, so they call it virtual metering. If you can, so they can use the BMS and they can calculate points and do virtual metering. One of our challenges is we don't have much for metering pulled into our BMS and pulled into our FTD solution. So I think there is some more direct energy monitoring possible. We just haven't enabled that. It's actually something I'm looking at because we have another EIS tool that has a lot of that, but it's not quite as mature. So if I can start kind of pulling those together into one platform, I think that's a direction we could get some additional value. But right now, yeah, sub-metering and metering have just not historically been pulled into our BMS, and thus far it's not easily accessible to our FTD solution.
Okay, thank you both very much. We'll move to the next slide here. Just got a few closing announcements. The first one is just to thank all the attendees here for your questions, and obviously to our panelists, Scott and Gary, for their insightful responses. This has been part of the 23-24 Better Buildings webinar series, and as you'll see on this slide, we have a great lineup of presentations through March, and you can go to the Better Buildings Solution Center to find out more and to register for all of these. If we go to the next slide, you'll see that next week at the same time, we have a webinar on Cool Runnings, the race to phase down industrial fluorinated gas emissions. Learn from leaders in Better Plants program, eliminating fluorinated gas emissions. The next slide is about the Better Buildings Summit. We're very pleased to announce registration for next year's Better Buildings, Better Plants Summit. This will be in Washington, D.C., April 2nd through 4th. Lots of engaging, interactive sessions, and also plenty of opportunities to network with your industry peers and experts. And you can explore the tracks if you go to the link on this slide here. Next slide here, check out season 1 of the Better Climate Challenge Roadshow as our energy experts hit the road to see how partners in the Nashville area have been reducing their emissions, such as Nissan, Whirlpool, Chemours, and you'll be able to see decarbonization in action. As a reminder, the Better Buildings Challenge, Better Climate Challenge, apologies, is a program where partners are on their way to meeting their goal of reducing emissions by 50% in the next 10 years, and this roadshow is a great way to see how they're doing with that. Next slide, please. With that, I would like to thank our panelists, Gary and Scott, so much for taking the time to be with us here today and sharing their expertise. Please feel free to contact the presenters directly and reach out to me if you want to join the technology research team for this kind of analytics and be part of more of these kinds of conversations. And look out for the Better Buildings Initiative on LinkedIn and Twitter for all the latest news. Now, you will all be receiving an email notice when today's recording, slides, and transcript are available on the Better Buildings Solutions Center. And with that, I would like to thank you all. Have a good day.